Hello there and welcome to A2 Maths from June 2018, paper 2, and here we're looking at question 8, a quadratics question. So figure 1 is a graph showing the trajectory of a rugby ball. The height of the ball above the ground h meters has been plotted against the horizontal distance x meters measured from the point where the ball was kicked. The ball travels in a vertical plane. The ball reaches a maximum height of 12 meters and hits the ground at a point 40 meters from where it was kicked. So let's draw that on our graph. We have a maximum height of 12 meters. It goes from x equals 0 to x equals 40. And by the symmetry of a quadratic graph, this 12 meter height is going to be measured after 20 meters of horizontal distance. Find a quadratic equation linking h with x that models this situation. Okay, so a few ways of doing this. The first way, and the way that I'm going to do it, is just by setting up a y equals ax squared plus bx plus c standard quadratic equation. Now I know that the curve goes through the point 0, 0. I know it goes through the point 40, 0. And for the maximum point, I also know it's going to go through 20, 12. So what I'll do is I'll plug all of these three coordinates in, get three simultaneous equations for A, B and C. One will be easy, I've already tried it out, and then we'll just work out the other two. So in this case here, trying the 0, 0 coordinate first. The 0, 0 coordinate will give us 0 equals A times 0 plus B times 0 plus C. So this must be the case that C equals 0, so I'm now going to ignore C moving forward. The next coordinate I'm going to plug in is 40, 0. So therefore I'm going to get 0 for the y coordinate is equal to 0 equals a lots of 40 squared, that's 1,600, plus b lots of 40. Okay, now moving on to the final point, 20, 12. So this is going to give us 12 equals a lots of 20 squared, that's 400, plus b lots of 20. Okay, so what we'll do, let's double this second equation. So we get 24 equals 800 a plus 40b, and we'll call this equation 2, and we'll call this equation 1. And we'll subtract equation 2 and equation 1. So equation 1 take away, equation 2 take away equation 1. I've made sure the b's are the same coefficient. So it's going to be 24 take away 0, that's 24, equals 800a minus 1600a, so that's minus 800a. And now all we need to do is divide by minus 800, so it's going to be 24 divided by minus 800. That's going to give us minus 3 over 100 as our value for A. Now all we need to do is plug it back into one of the equations to work out B. Let's choose equation 1. 0 equals minus 3 over 100, lots of 1,600, plus 40b. So therefore, cancel out the 100 there and there. 3 times 16 is 48, so add the 48 on the other side, so 48 equals 40b, divide by the 40, and the simplified fraction is 6 over 5, so b equals 6 over 5. So therefore the quadratic is y equals minus 3 over 100 x squared plus 6 over 5x. Lovely, so there we are, that's the answer to part A then. Moving on to part B, the ball passes over the horizontal bar as a set of rugby posts is perpendicular to the path of the ball. The bar is 3 meters above the ground. Use your equation to find the greatest horizontal distance of the bar from O. So okay, so we put some rugby posts here, and the bar on the rugby post is 3 meters high. So what we want to find is the x coordinate that gives us a height of 3 meters. It's probably going to be 2 x coordinates. We want the second of those x coordinates. So we've got y equals minus 3 over 100 x squared plus 6 over 5x. We want the y coordinate to equal 3, so let's set it equal to 3. We'll solve the equation for x afterwards. Okay, so let's now times everything by 100. That should simplify it. 300 equals minus 3x squared plus, now let's be careful on this one, times 100 equals 120x. Let's divide by 3 as well, so 100 equals minus x squared plus 40x. Let's now move everything onto the left-hand side. X squared minus 40x plus 100 equals 0. And now let's plug this into the polynomial solver. The two solutions that we get are, well, it's going to be x equals 20 plus or minus the square root of 300. So it's going to be the second of those, because obviously you can remember we can set the post up to be here, but we want the maximum horizontal distance that the ball can travel. So it's therefore going to be x equals 20 plus the square root of 300. As a decimal, that's going to be 37.3 meters from the bar. Okay, so there we are. Give one limitation of the model. Well, there could be wind resistance, there could be the ground might not be horizontal, the ball needs to be kicked from the ground, the ball is modelled as a particle, lots of different limitations for this model, so we'll pick one. Let's say that it doesn't take account of air resistance, no air resistance. Or wind direction. Okay, so there we are. That's the answer to question 8. That's 7 marks.